history of time or mankind, we'll try to figure out ways that the universe works or how things in general work as a whole. Like the Big Bang Theory or God created everybody. Anyway, more recently, physicists have proposed the idea of string theory, which basically states that, it attempts to provide an explanation of how all the constituents of nature interact with each other. Before fully understanding string theory, you would have to also understand a little bit of quantum mechanics and Einstein's theory of general relativity, which isn't as simple as it sounds, and I can actually, I think, explain it in 6 to 8 minutes. So, starting with Einstein's theory of general relativity. Okay, so we all know the Newtonian model of the universe, right? We have the sun. We have the sun at the center, and the planets, these are planets gravitating around the sun, and they're pulled towards the sun in a gravitational pull. For a long time, this was how people thought the universe worked. This is just how it is. However, what Newton didn't do was explain why we were pulled towards the sun. He could observe gravity and explain that we were being pulled in a gravitational pull, but he couldn't say why that was. So we have Einstein, who, centuries later, came up with the theory of general relativity, which basically states that instead of operating on 3 dimensions and then the separate dimension of time, they kind of interact with each other and form this fabric of space-time like this. Which, this is a side profile, which is, think of it, as this. So this is the fabric of space-time, and in the middle, you have the sun, which creates a sort of dent in this whole fabric, like, when you put a ball on, a sheet, it goes inside the middle, creates a dent, and it has, ripples around it, or not ripples, but different fluctuations in the fabric, and that's where the planets are. They operate on this whole gravity pulling, or not gravity pulling, but it's just, that's how it works because it's time. Okay. So basically things are all connected, interconnected like this, where it's not just we're being pulled, but we're all operating together. So the theory of general relativity more or less states that things can be specifically predicted in the universe. Okay. That's the theory of general relativity. Moving on to quantum mechanics, it deals with things on a subatomic level, which, we have atoms, and then we have what's smaller than atoms. Because we all know that the smallest particles are atoms, right? Everything is made up of atoms. We all learned that in elementary school. However, physicists have said that, or have found out that there are smaller particles than electrons, and protons, and neutrons. They're smaller, they're called quarks. Okay, so we have these quarks, and they interact with each other in a way that we can't really predict. It's more random. Things on that more subatomic level are a game of chance, so to speak. Okay, so we have the theory of general relativity, which states that everything is predictable, and quantum mechanics, which says that things are chaotic. And these are the 2 leading theories of as to how life works. But they split. They don't work together, right? You can't have chaos and predictability. It doesn't work, right? Right. Okay, so string theory. Okay, look at from far away, right? This kind of looks like a point. Am I right? Okay, yes, I'm right. So string theorists or physicists have actually come up with this idea that things aren't points like this. They don't look like these points. Things are actually strings. This. And this is what the Earth or the universe is made up with. They vibrate and they fluctuate and they change and they create different particles when they move or they oscillate in different ways. For example, if whatever energy stream were to vibrate in this way, you create a proton or a hydrogen atom. Okay, that's what happens when it vibrates. It's like like a guitar string, you know, you have it, and you pluck it a certain way, it creates A. Pluck it a different way, it's G or C, the C note, you know what I mean? Yes, great. Alright. So, Brian Greene, who is a leading string theorist and physicist, states in his book, The Elegant Universe, string theory is the most advanced idea of bringing these two ideas, the general relativity and quantum mechanics, together, which is what Einstein wanted to do. He wanted to bring these two ideas together because people want to find out the answer as to how things work. They can't settle on not knowing, right? So that's what string theory attempts to do. You know, recently we built a hydrogen collider, which until then the string theory wasn't really able to be proven completely. So again, it's not falsifiable. However, there's a lot of theories out there that are falsifiable as well. I mean, you can't prove God to me. So string theory is just another attempt that we have come up with to describe how everything works. Which, I don't know, it's pretty interesting if you consider it. And I think you should consider different things when, you know. So. Anyway, so string theory, combination of quantum mechanics and general relativity.
So Teresa, what did you think?
I didn't think it was very organized very well. I couldn't kind of hard to find the pieces. But like the visual aids, they were like big and colorful and easy to see. I liked how you used the rubber band. And you did have some citations, but there's only one. And yeah.
All right, Sarah, I think you've got a great topic here, and you do some things with it that are really interesting. It's basically kind of a definitional speech explaining what this concept is, but I do think that there are some structural issues here. There's not really a clear thesis statement. There's no layout of how we're going to get at the subject. Now, once you start talking, it's pretty easy to follow. You've got the theories that you have at the beginning. You're talking about Newtonian principles, then you're talking about relativity, and then you're talking about quantum physics, and ultimately that leads us to string theory. All right, so there is kind of a structure to the material, but all of the stuff that comes before string theory sounds like it's grouped in one section that's really kind of background information for us to understand once we get to string theory, which I can live with. That would be fine, but you need to tell us that's how we're getting there. Once you get to string theory, it just seems though that it's a little bit more random, which I guess might work with string theory. You know, it's being vibrated at a different tempo, and so we're getting different results. But it needs to be a little bit more focused, and I think that's where you're missing a trick. I thought your explanations were actually pretty good most of the time. Once you got to the visualization with the rubber band, I think you needed to have a clearer transition and a clearer explanation, because this is the key point in your speech, and you seem to be kind of, falling into it instead of having planned it out. And I think that's a little bit of a problem. You do get a little distracted with that rubber band early on in the speech. I'd keep it out of your hands until it's time for your example, because you're playing with it. All of your nervous energy is coming out there. All right, thank you.